Hello, in this video we will explain Newton's law of universal gravitation. Newton knew that if an object is not moving in a straight line with a constant velocity, then a force is responsible. How can we describe the motion of objects in space? Recall that forces are classified into two categories, field forces and contact forces. In nature, we experience three field forces: the magnetic force, the electrostatic force, and the gravitational force. Magnetic forces are forces that exist between magnets and magnetic materials. Electrostatic forces are forces between charged objects. Gravitational forces are forces that exist between masses, any two masses, massive objects like celestial bodies and infinitely small ones like particles of matter. But how is the gravitational force different than both the magnetic and the electrostatic forces? Magnets have two different poles. Charges could be positive or negative. Masses don't have two types. This is the reason behind the existence of attraction and repulsion in both the magnetic and electrostatic forces, while the gravitational force is always an attractive force. Consider two spheres of masses m1 and m2, whose centers are separated by distance d. There exists a force of attraction between the two masses. Due to the principle of interaction, the force exerted by m1 on m2 and the force exerted by m2 on m1 are related by this equation. The force vector m1 on m2 equal minus the force vector m2 on m1. It means that the two forces have the same line of action, opposite directions, and the same magnitude. What are the factors affecting the magnitude of the gravitational force? When the magnitude of one or both masses increase, the force will increase. And when it decreases, the force will decrease. Keeping the magnitude of both masses constant, when the distance between the masses increase, the force will decrease. When the masses become closer, they attract each other more. This leads us to the law of universal attraction that states, any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers of gravity. We can express the law as F equal g m1 m2 over d squared, where F is the magnitude of the gravitational force between the two masses expressed in newtons. m1 is the mass of object 1, m2 is the mass of object 2, both expressed in kilograms. D is the distance between the centers of gravity of the two masses. The SI unit of distance is meters. G is the universal gravitation constant. The value of G is 6.67 times 10 power minus 11 SI units. The constant G exists because we are expressing the values with conventional SI units. F equal G m1 m2 over d squared. Rearranging the equation, we get that G equal F times d squared over m1 times m2. The SI unit of G is then Newton times meter squared over kilogram squared. This table shows each quantity in the equation with its SI unit. Now let's check your understanding. Please read the question, pause for more time and try to solve. We reached the end of part 1 of law of universal gravitation.